CAM-Assist is an AI tool that generates toolpaths for CNC machines, allowing users to accelerate CAM programming lead times. Here are 5 fundamentals to get the best results out of CAM-Assist. The quality of the CAD model is everything. Importing a good quality CAD model into CAM-Assist is crucial, as any imperfections in the CAD model will likely be translated into the tool path itself, affecting the overall quality of the program. Here's an example of a poor quality model. The yellow shading indicates that there are surface entities overlaying some faces. Zooming in here, there is a split in this surface between the fillet rad and wall. Surface breaks between faces in the model can lead to CAM-Assist not recognizing the affected surfaces as part of the solid model, which can result in gouges and collisions. Moving over to the end of the fillet rad, there are some surface overlaps. This can cause excessive material to be left on these areas of the part model. On closer look at these holes, they are actually made up of split surfaces joined together. Due to this, CAM-Assist may not actually recognize these features as holes, as it technically interprets them as individual surfaces stitched together. This can prevent the intuitive selection of a drill tool to produce the hole, resulting in helical machining of the hole with an end mill instead. Here's an example of a good quality model of the same part. This model is a single entity solid body. Visually, it looks clean, without any of the imperfections seen previously with the poor quality model. CAM-Assist is only compatible with solid models. Any individual surface entities should be deleted. If the model is made entirely of surfaces, it will need to be converted to one solid entity before running CAM-Assist. So, to summarize, here's a list of do's and don'ts regarding CAD model quality for maximum compatibility with CAM-Assist. Define your work holding within each of your setups. When using CAM-Assist, the user must create their setups and define their work holding. The methodology and number of setups used to machine any given part can depend on multiple variables, some of which are unknown to the AI. For this reason, it is best to leave defining the method and number of operations to the skilled machinist, using CAM-Assist to generate the toolpath. It is critical to define the work holding within each setup, as this plays a vital role in CAM-Assist toolpath generation. This is because the defined work holding area helps CAM-Assist understand the maximum depth that the toolpath can go to for each operation, ensuring that the toolpath does not collide with the fixture area. It is vital that the user reviews the toolpath generated by CAM-Assist before post-processing any code to the machine. In the unlikely event of a collision, the user will be alerted to the issue when reviewing the program if the work holding is defined in the setup correctly. Create avoidance geometry for more control over toolpaths. When using avoidance geometry, make sure it is constructed of one single solid body entity. Avoidance geometry can be defined within the CAM-Assist setup. This additional geometry will be taken into account when generating the toolpath. The purpose of avoidance geometry is to blank off areas of that part that you don't want the toolpath to gain access to from any given machining setup. The one exception to this being hole-making operations, which ignore avoidance geometry, allowing holes to be drilled. For this reason, avoidance geometry is a critical tool that can be used to gain more advanced control over the toolpath and machining process generated from CAM-Assist. Let's hit run and see what the toolpath looks like with the selected avoidance geometry. In this example part, the avoidance geometry has been used to maintain the thickness of the base and not allow the toolpath to go underneath the part in 3+2 axis automatic mode. Here it is without the use of avoidance geometry. The toolpath is allowed to gain access underneath the part. This may lead to a collision with the vice jaws as well as the part becoming less rigid, which would cause issues with excessive vibration. Ensure that your tool database is compatible with CAM-Assist. Investing the time to develop a comprehensive tool database is a key step for success with CAM-Assist. A good tool database should be a like-for-like digital representation of the tooling that you have in your factory. Even without AI, a well-defined tool database will streamline your manufacturing process, eliminating the need for repetitive work such as building the same tools and calculating the same cutting parameters every time you program a new part. When combining this tool database with the AI, productivity is boosted even further. It's also critical to have a solid tool database to get the full benefit of CloudNC's cutting parameters, which is a tool that can generate physics-based cutting conditions once it understands how each individual tool is defined. So let's take a look at some of the key points when creating a tool database compatible with CAM-Assist. The first critical thing to highlight is that only a complete tool assembly will be recognized by CAM-Assist. If the tool is defined on its own without a holder, it will not be imported into CAM-Assist. The 5 default material usages must be configured correctly in the tool database to be recognized by CAM-Assist and cutting parameters. If you have existing and proven cut parameters, they must be named correctly in the tool database to be recognized by CAM-Assist. If you are unsure of the correct naming conventions, refer back to the Imperial or Metric Sample Tool database, which is downloaded onto your local hard drive when you install CamAssist. Part selection for compatibility with CamAssist. CamAssist can be used to accelerate programming time when making parts consisting of various geometries from a wide range of industries. Let's take a look at some examples of parts and assess their suitability with CamAssist. The AI does not currently support turning applications. This should be considered when selecting parts to program with CamAssist. Here's an example of a part highly compatible with CamAssist. The AI would program this part with ease, competing between 90 to 100% of the part. This part is of average complexity. In this example, the AI would provide around 70% of the program, leaving the skilled user to make some refinements and optimize the program before sending it to the machine. This part is not ideal for CamAssist at this moment in time. The toolpath completion rate would be around 30%. CamAssist does not currently support part geometries that require full simultaneous machining, leaving all simultaneous roughing and finishing strategies to be programmed manually. So to conclude, AI is a very powerful tool that will amplify the efficiency of your shop. But just like a good employee, CamAssist needs to be given all the necessary tools and information to provide the best results, allowing the AI to perform to its maximum capability. Download CamAssist and give it a try today.